Hello, good people. Welcome to the first video of 10.7 alternating series test. So far we've been looking at infinite series whose terms are positive, right? We just keep adding a positive term times another positive term plus another positive term plus another positive term. But what if they were to alternate? And what would cause them to alternate? So, one of the things that causes an alternating series, not always, but is this device, I call it a device, where I have negative 1 to the n. Because if you think about it, if I go from 1 to infinity of negative 1 to the n, when I substitute 1, negative 1 to the 1 power is going to give me negative 1. Plus, when I substitute 2, negative 1 to the second power is going to give me positive 1. Plus, when I substitute 3, and so on and so forth, right? So this is going to produce an alternating negative, positive, negative, positive, negative, positive. By the way, if we do this, negative 1 to the n plus 1, then the first term would be a positive 1 plus a negative 1 plus a positive 1 plus a negative 1. So really that just changes which sign I start with, right? Positive or negative. There's different ways to create alternating series, so I don't want to say that this is the only way or these are the only ways to create alternating series, but this is the most standard way to do it, right? Okay, so if I know I have an alternating series, then how do I know if it converges? So if I were to take my alternating device out of the way and just be left with the a sub n formula, if that's only producing positive numbers, then I know that the alternating series is going to converge if two things happen. Number one, the limit of a sub n as n approaches infinity is 0. So my terms are getting smaller and smaller and smaller and approaching 0. And then the second thing is a sub n is decreasing. Well, how do I know it's decreasing? Well, that would mean that a sub n plus 1, the next term, has to be less than or equal to a sub n, the current term, right? So the first part I think is easy to do because we've been taking limits since unit 1. The second one maybe a little bit harder to check. And so here's some ways you can check to see if a sub n is decreasing. Number one, you could take the derivative, because remember we said if you take the derivative and you produce a negative uh, from the derivative, a negative derivative value, then the function is decreasing. So I could do that. That could take some time, and depending on the formula, it could be really, really yucky. Usually, it's obvious that they're decreasing. But the third way is we could manipulate this expression, right? This expression just says for any n value, so let's say n is 3. For any n value, a sub 3 plus 1, that would be a sub 4, is less than or equal to a sub 3. The next term is smaller than the previous term, right? That's what that's saying. So what could we do? Well, we could subtract both sides by a sub n, and this is equivalent to saying a sub n plus 1 minus a sub n is less than or equal to 0. So if I can show this, that would work. Or I could also say divide both sides by a sub n, and then I could rewrite it as a sub n plus 1 divided by a sub n is less than or equal to 1, because if I divide both sides by a sub n, this becomes 1. That's another way to show it. So there's multiple ways we can show it, but we do have to check. These are the only two conditions that we need to check. We need to check that the limit is approaching 0. We need to check that the function is decreasing or the sequence is decreasing. Now, if you read carefully, the alternated series test only tells you whether the series converges. It doesn't tell you if it diverges. So if one of these conditions is not met, then I can't use this test and I got to find another way to figure it out. Okay, here we go. First example, and then we'll come back with the second video for some more examples. But just looking at this example, is this an alternating series to begin with? Well, yes, because if I substitute 1 into my ends, I'm going to get negative 1. Plus, substitute 2 into my ends, this will become a positive 1, and this will become 1 half. Plus, if I substitute 3, this will become negative 1, and this will be 1/3, so that'll be negative 1/3. Plus, and so on and so forth, dot, 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 right? Now, do you recognize this as a familiar pattern? You probably do. This is a harmonic, except it's alternating, so we call it the alternating harmonic series. Now, if those negatives weren't there, we already know that the harmonic series diverges, but now we have alternating signs. Does that make a difference? Well, that's what we're about to check. So let's check. We're going to take the limit as n approaches infinity, not of the whole thing, but of the formula, not including the device that changes the signs, right? So 1 over n. So we're basically doing the limit of the absolute value. We only want the positive part of the formula. Well, obviously, this equals 0. So that first condition is met. Second condition is 1 over n, or I guess I should call it a sub n equals 1 over n. Is it decreasing? Well, if you look at the numbers, we're stripping away the negatives and only looking at the numbers. 1, 1 half, 1/3, 1/4. Are they getting smaller? Yes. So therefore, I can say that the series, let me use a different color, the series converges by the alternating series test. So this is kind of weird because the alternating harmonic series, if I alternate signs, this series will converge. But if I take away the negatives and just make them all positive terms, that's a harmonic series that's going to diverge. Does that always happen? No. But in this special case, it does. We're going to take a pause here. We'll come back in video 2. We'll look at number 2 and do some of these other ones, especially things like number 4.